So recently on Brandon's show, there's been talk about using the subpolar points of the sun, and this is when the sun is directly over a location on Earth, to measure the speed of the sun. And of course, this is an attempt to prove that the Earth is flat. Now we know that the most northerly orbit of the sun is over the Tropic of Cancer, and the most southerly is over the Tropic of Capricorn. So at these locations, the sun would appear to move the slowest and of course the fastest over the equator. But on the flat Earth, the sun would appear to be the fastest over the Tropic of Capricorn. So the idea would be to get a couple people somewhere in the southern hemisphere close to the Tropic of Capricorn along the same latitude. So the person at point A would note the time when the sun was directly overhead, and the person at point B would do the same thing. And then you could calculate the sun speed by dividing the distance between those two locations by the time. Now, what this experiment really shows is their lack of understanding of some basic concepts. And the first one is this one right here for the circumference of the equator on a flat Earth. Where did they ever get the idea that it would be 24,901 miles? Now, the circumference of the equator on the globe is 24,901 miles, and you use this formula over here to make the calculation. That is 2 times pi times the radius. Now, the distance on the surface from the North Pole to the equator is 6,215 miles. So on a flat Earth, the radius of the equator would be 6,215 miles, and when we plug that into the formula, we get a circumference of 39,050 miles. So if we compare the diameter of the equator on both the globe and the flat Earth, we can see that the flat Earth is quite a bit bigger. In fact, the flat Earth Tropic of Cancer diameter is even larger than the globe diameter at the equator. So it is quite evident that distances on these two models would be quite different, and especially in the southern hemisphere. For example, if we compare the US to Australia on a globe, we can clearly see that the east-west distances are about the same. But on a flat Earth, it's quite evident that Australia is about twice the distance east to west as the United States. And if all maps conform to the globe, but we live on a flat Earth, you think by now somebody would have maybe noticed this. Now, another concept they are struggling with is the apparent motion of the sun. So the first thing they need to understand is that longitude lines have the same solar noon. So if you're in this location right here, the sun is directly overhead, that is solar noon. It is also solar noon for everybody along this longitude line. Of course, you also need to understand is that solar noon can be a different time than noon for your local time zone. Now the sun also travels at 15 degrees per hour, and here we have two longitude lines that are 15 degrees apart. So it doesn't matter what your latitude is, the amount of time it would take the sun to travel from this longitude to this longitude is always going to be 1 hour. So if they had 3 pairs of individuals, one at the Tropic of Cancer, one at the equator, and one at the Tropic of Capricorn, and they measured this sun here from solar noon to solar noon, they would all come up with the exact same time of 1 hour. So you don't even need a subsolar sun to do this experiment. And what this shows us is that the sun speed is an apparent speed depending on your latitude. So of course on the globe it's going to appear to be fastest at the equator, and then it would get slower as you head farther north or farther south. Of course they are convinced that we live on a flat Earth where the speed of the sun actually changes from the Tropic of Cancer to the Tropic of Capricorn. But again, even on a flat Earth, longitude lines have the same solar noon, and the sun appears to travel at 15 degrees per hour. So these 3 pair of observers measuring this sun from solar noon to solar noon would come up with the exact same time of 1 hour. So the reality is you don't need to do the experiment. You just need to measure the distance of latitudes between longitude lines. Of course, how are they going to measure this distance? Are they going to use Google Earth? Well, here is an easy solution. We can use commercial aircraft because all the big companies use Airbus and Boeing, and these aircraft fly at the same speed of about 547 to 575 miles per hour. And an easy way to do this is compare flight times across the United States in the Northern Hemisphere and Australia in the Southern Hemisphere. So on a globe model, they should be about the same time. But on a flat Earth, the times across Australia should be noticeably longer. So let's start by comparing a flight from Sydney over here to Perth on the west coast of Australia, and on Google Earth that is a total of 2,040 miles. Here's a Qantas flight between the two cities, so from Sydney to Perth, 5 hours 5 minutes, and the return flight is only 4 hours and 5 minutes. Now it's not uncommon to see a difference in the different directions because of prevailing winds. So Sydney to Perth is probably with a pretty good headwind, and the reverse flight is with a good tailwind. So that's why I'm going to use the round trip total, and that would be 9 hours and 10 minutes. Next, we'll take a flight from Washington, D.C. to Las Vegas because it has a similar distance of 2,066 miles. So on this flight, D.C. to Vegas is 5 hours and Vegas to D.C. is 4 hours and 31 minutes. So now we have a round trip of 9 hours and 31 minutes. Well, this is very strong evidence supporting the globe. Here we have two distances that are only 26 miles in difference, and the round trip times are within 21 minutes of each other. Now here I took a cutout of the United States on the flat Earth map, and I superimposed it and I lined up the longitude and latitude lines, and this gives us a better comparison of the east-west distances between these two countries. So on this map, it's quite easy to see that the distance from Sydney to Perth is quite a bit longer than the distance from DC to Vegas, and yet we actually have a round trip flight time that is about 20 minutes less. Now, unless they have jets down here that are flying twice as fast as they do in America, I don't think this is very good evidence that we live on a flat Earth. Now, instead of just using flights from these two locations, I'm going to bring in two more locations. And this one is near the Tropic of Cancer, you can see right here. So this is from Dubai to Kolkata, which used to be called Calcutta. And the distance here is about the same, 2,096 miles. So this is a flight on Emirates Airlines, which is based in Dubai. So from Dubai to Kolkata, we have 4 hours and 40 minutes, and from Kolkata to Dubai, 4 hours and 55 minutes. And that is a round trip of 9 hours and 35 minutes. So this is a flight near the equator. I was hoping to find something that was more parallel to the equator. I looked in Africa, I looked in South America, I even looked in throughout Indonesia up in here, but these are very remote areas. I've traveled throughout this region, and most of the time you're going to be on little turboprop planes, otherwise boats. But if you're a scuba diver, I would highly recommend visiting Indonesia. There are some fantastic dive sites. But anyways, this will be a flight from Singapore to Darwin in Northern Australia. So Singapore to Darwin, 4 hours 45 minutes, and the exact same time in reverse. That's pretty rare. But anyways, we got a round trip time, 9 hours and 30 minutes. Now, all of these distances are within 56 miles of each other, and if you look at them on a globe, you can see they are the same size. So considering that all of these round-trip flights are within 25 minutes of each other, I think this is very strong evidence that these distances match the globe. It is also quite evident on a flat Earth that these distances vary quite a bit, even though they should be within 56 miles of each other. So again, evidence shows that we live on a globe.